Hey everyone, so this is one of our videos from the Acer HQ. We're actually in the design center. We have some cool shots from around the design center of some of the rapid prototyping tools. Really interesting space. Maybe we'll talk about it in more depth in a future video. But for now, what we've already covered and should be on the channel is the Orion X. Particularly interesting mini-ITX chassis. And the difference from when we showed it last time is now there's no video card in it. And that's because we're going to take it apart. So this already on the channel. I'm not going to spend more time on it in this video. What we're focusing on today is the video cards. If you saw our previous coverage, I want to say it might be the only time we've covered an Acer product. I'm not sure. I don't think we've done a pre-built. But we covered the Arc GPU. And the Arc GPU was actually pretty interesting. Unique design. The thing that caught our eye for it, and the reason we bought it to even test, was one, because Intel Arc. And the only other vendor at the time was basically ASRock. And then two, it had the mix of blower fan and axial fan. So that's already on the channel. But Acer is clearly trying to get more into video card design. And that's what we're looking at today with a teardown of this 4090 that has a liquid cooler built in. And I've also got a future AMD design that we can briefly show, but because it's early in design, we can't go too much into details because stuff may change. So let's get started. Before that, this video is brought to you by Montech's Metal DT24 base. This two-fan tower cooler keeps a simple black and metal look to match most build aesthetics, and it runs a 6 heat pipe design with 2 towers and 2 fans for higher performance air cooling. The Metal DT24 base can also accommodate taller memory modules because it cuts back the fin stack closest to the first DIMM slot. The Metal DT24 base uses a standard mounting mechanism and is easy to install. Learn more at the link in the description below. Okay, so this is the one of interest today. We get to take this apart, and the number one disclaimer here, this is an engineering sample. So this is used for design decisions, for initial testing, and it's not a final production sample, which means you're gonna see some cosmetic damage from use in testing, but it's not representative of the final. We'll probably look at the final once we get the Orion X in. With that out of the way, the reason this is interesting is once again because they've got a 3-slot design here, and for cooling it's 2 axial fans, which if I recall are 100 millimeters, 10 centimeter fans. Those are attached to a shroud. Underneath is a liquid or a radiator, which has the dual pump on one end of the radiator rather than centrally. Last time we saw radiators in cards were the Fury X as an example, which was probably a mistake AMD won't make again, and then the Alienware card with the weird expansion thing. So this one's fully integrated. Center's got the cold plate. We're gonna check it out internally, but before taking this one apart, let's look briefly at this one. We're not gonna take this apart today because it's just too early in design to really get into. So this is a triple axial design. It's much more standard in that regard. They've got some interesting shroud in here, so rather than taking the whole shroud area, surface area, and coming out to the full edges, they've basically just kind of chamfered the edges around the fans and sectioned them off. This is, as you can see, a Radeon design. Acer's still working on it. This is an early prototype, so it's not final yet. Things will change. But just from noticing what they've got going on right now, there's base plate here. Base plate extends and comes all the way across. This is a wide PCB, so in theory, the full PCB should be populated. I actually see an unpopulated connector over here as well. And it's not going to be a flow through, at least right now, and assuming nothing changes. But instead, a more traditional 3-axial fan into the PCB with exhaust coming vertically top and bottom of the fin stack, which is fully exposed here. And this, it seems like manufacturers have kind of finally figured out, but there was a period where XFX in particular, they were all blocking the vertical fin stack. So it's like they set up a fin stack to exhaust vertically, and then they would blow all the air into a plastic shroud, which was terrible and it didn't work. And I think we finally figured that out as an industry. So this one is kept more open, which, you know, should be a given, but with companies entering the space, they don't necessarily always do what the incumbents know at this point. Acer is going in the right direction with that, so we'll probably be looking at this one once it comes out too. Let's get into the 4090. I have not done any kind of preview or pre-briefing on this, so we're gonna figure it all out together here today. There are a couple screws that are removed already, and as I said, that's because it's an engineering sample, so this won't be fully representative, but it'll be pretty close. 4 screws here going into the cold plate area, retaining probably that whole heatsink to the PCB. I see also, you can tell from the markings here, there's going to be a couple screws underneath, with the screws coming up and through the PCB and into the backplate probably, so we'll find that. On the edges here, we've got a couple that, actually that one's unscrewed already. Got a couple that are going through the PCB and into a retention plate, the radiator. These designs are always interesting to me because they can work really well or they can work really not well. And you don't know until you test it. But with 4090s, there's just so much heat flux and power to deal with. It can be more beneficial. I don't think this screw is supposed to be this chewed up, but it's the backplate. Backplate's free. No cables. So there's a backplate design. It looks like some area for air to come throughout the back over here, but otherwise pretty simple design. Because this isn't a final retail sample, we would have to look at a retail one to make commentary on things like thermal pads and their presence. For the back, you can see inductor line here, MOSFET line, there's another one over here, so they've got a VRM on both sides of the GPU. It's actually really beneficial for higher power, larger core designs for the bigger silicon, because as the voltage regulator is handling the power delivery to the GPU core, splitting across 2 halves of the PCB allows higher efficiency reaching the different parts of the core that it needs to reach. And then memory VRM we'll look at once we get to the other side. Let's pull these 4 screws. Nothing particularly interesting on the back. It's pretty standard. It's a couple controllers. But this is so far going quickly. I think we're probably going to take these out next. Actually, the I/O plate's pretty interesting on its own. There's a ton of punched out holes on it, which is good. That allows air to get through. And otherwise, it's a 3DP1 HDMI. I'm glad we have video evidence that there's already screws missing so that I can't be blamed for it later. And they are using, this is actually also noteworthy, Acer is using the full 3-slot bracket. For some reason, this is not common for 3-slot video cards. A lot of them end up running just a 2-slot bracket for the larger card. So these actually, NVIDIA made a really big point about this in their own FE design, where NVIDIA was attributing a lot of the structural rigidity to going for full 3-slot to help prevent some of the sag on the card, along with their X frame. I think, does it separate now? I'll try. Yeah. I might do the fan cables. Yeah.
Oh, yes.
Yeah, okay.
Just some more pain.
Yeah. Just pulling the fan cables. A lot going on this PCB. So for cabling, first of all, I got 3 cables running to the board that I can see anyway. And one of these is going to be for pump at least, and the other 2 are probably for fans, LEDs, things like that. Board layout, so we've got 12-volt high power up here. A couple shunt resistors up there as well. 2 milliohm shunt resistors. There's a 5 milliohm shunt resistor down here if you wanted to, and there's another 5 milliohm up here. So options remain if you wanted to short those to increase the power target, which might make sense on this given that it's liquid cooled, assuming the cooling works well. Full 4090 fat die, and that is attached directly to, actually let's just get this cable out of here securely. Always pull at the housing. Okay. All right, so here's the cooler. Points of interest. Cold plate has a protruding copper brick that comes out to contact the GPU core. You see this sometimes on the old EVGA CLCs. This was actually the EVGA hybrid CLCs. This was actually really beneficial for them. The reason it worked great for EVGAs is because they were able to flatten the contact patch much better than on the Asetek like concentric ring plate that they used to use. Because with GPUs, there's a little bit of a curvature to it, but this is significantly flatter than say an IHS or something on a CPU. So sometimes these protrusions, I don't know if this is why Acer did it or not, but can be beneficial for improving the contact, the flatness, and the pressure distribution. You see some torque screws here that are attaching the cold plate to, it looks like where the microfins, yeah, so opposite side of this cold plate, there's gonna be microfins inside of the block. I guess there's no pump in there, so it's not a pump block. And then I'm assuming this side with the pumps?
Yes.
Yeah, so dual pump over here, and it looks like you can actually see them. So this plastic protrusion here, and then there's another one here. That's probably where the pumps are located. So for radiator dimensions, just got this from the team here. So it ends up being a 227 mil wide. So you've almost got like a 240. Thickness is 22 mil, and that keeps it within the 3-slot sizing. They've got some shroud components here that are just plastic embellishments. There's a couple screws that look like this may be more of an engineering sample artifact here, but connecting these plates to the rest of the radiator. I'm guessing this has liquid in it, right?
Oh,
This has liquid in it?
liquid,
Yeah.
just
Okay,
liquid.
so I won't take that off then.
You cannot
Yeah. I'll leave it. Yeah, I'll leave that on. So this is actually I guess a functioning unit. It's got liquid in it. We're not going to take this out and look at the microfins. The microfins are pretty standard though. More evidence of engineering samples though. This is kind of a cool story in terms of seeing what goes on to design a product, because they've got stacked thermal pads on thermal pads, which in an end product you would ideally never do this. You would just get a custom made pad, but the thicker pads when you're at like 4 mil are not normally off the shelf or easy to get. So stack pads there. But otherwise, memory is all sharing the GPU cold plate. So the memory is effectively cooled by liquid as well. The VRM is sinking into these contact plates, which I don't know how well we can show this. I'll try and show this camera. So at the bottom, from our perspective of the contact patch for the MOSFETs, there's actually a fin stack, and that's true for the one over here as well. So there's some extra surface area they've hidden down in here to leverage more of the space, and then it does eventually connect to the liquid cooling to the radiator. So, I mean, I think that really more or less shows it. There's not much point in taking the rest of this off, although there is only one screw holding it in, so we might as well. Normally I would just stop there, but let's just take the one screw out. It may be held in by a cable. Nope. Okay. Cool. That's pretty cool. Okay. I was going to make a comment that's really easy to disassemble, but there would be more screws in the final. So here's where the block ends up living. There's the pumps. This could be used as a fill port. I think in manufacturing that's used. If it's left with that cap screw in it, then as a user you could refill it as well. Inside of the housing here, so there's some, actually not foam. So this is the bracket for the fans. There's a PCB up here, which I'm assuming is for an LED, and then the fan wiring, which because it's an engineering sample, I won't comment on the wiring right now, but I think that's pretty much it. So that's the Acer 4090. This is not being sold standalone right now, but Acer's plan is to try and move towards more standalone video cards. So you see that with the Arc stuff, see that with the AMD one we showed you for a future project. NVIDIA is a little pickier about who gets to put NVIDIA's name on things, so I don't know if they've gotten through that process yet, but either way, if you're interested in this type of stuff, basically post in the comments, because that's the only way it gets out of this box and onto just a retail listing. So anyway, we'll try and test it standalone once it's done regardless. Thanks for watching. Check out the other video on the channel. Go to store.gamersnexus.net or patreon.com/gamersnexus. Help us out directly, and we'll see you all next time.